Welcome to the 29th Annual Exhibit of Hydrogen Fuel Cell Technology at Hanover Fair. At the Technical Forum, we really get into the details of this industry and talk about specifics. And we always have professionals here who know the insides and outsides of this industry from their own product perspective. Up next on the stage is EFOY Hydrogen Fuel Cells for Mobile and Stationary Applications. That is the topic addressed by Michael Weis, who's Business Development Manager H2 at SFC Energy. Please welcome Michael Weis.
Thank you very much, ladies and gentlemen, for joining and taking the time to have me introducing to you SFC Energy and our fuel cell solutions. My name is Michael Weis. I'm working as a Business Development Manager at SFC in our headquarters in Bruntal. So what is SFC doing? What's the purpose of the company? Basically, you could summarize it to the claim, goodbye diesel, green energy everywhere. And to put a handle on this, I've made up a very brief calculation about this. So if you have a diesel generator running with 5 kilowatt 24/7 for 1 year, you would emit roughly 45 tons of CO2 that can be completely saved by using hydrogen fuel cells. And to put it even more significantly, what we are seeing in the market is that diesel generators are usually heavily oversized to what they really need to achieve. So to give you an idea about how diesel generators are sized and how we are working, this graph on the right upper side will help you. So what we are usually seeing is these diesel generators are sized in a way that you are summing up the loads you're expecting, then you put a certain safety factor on it, and then we have the size of the diesel generator. With a hydrogen fuel cell, you have the possibility to directly fit a solution to your demand, meaning you cover the average load with the hydrogen fuel cell, and only the peaks are really supplied by battery systems that are integrated into the fuel cell solutions. So this way, you can have a very high efficient operation on your specific demand on site. We are covering this claim by basically 2 different technology lines. Up to 125 watt, we are using direct methanol fuel cells. And from the tipping point of roughly 1 kilowatt upwards, we are using hydrogen fuel cells. So you might think 125 watts, what is that? For me, it's always surprising how many applications can be solved with this small numbers. To give you an idea, on the upper left side, we were able to maintain the power demand for a mission called Moses in the Arctic. Also, we are covering the demands of CCTV applications on construction sites if the grid availability is not there yet. And of course, it's also a very important application field, the long-term measurement, for example, for wind applications offshore, where you have really high cost to maintain the energy supply. And this is where the 125 watt systems are very, very relevant. Nevertheless, we are talking hydrogen here, so let's move on to these applications. For hydrogen, we see basically 2 big market segments. One of them is the stationary market, meaning the energy supply for off-grid, the energy supply for critical infrastructure, for example, telecommunication towers, electrical substation, backup power for IT data centers. On the other hand, of course, we have mobile applications like construction sites, events, short-time usage of hydrogen fuel cells. And this is the 2 segments we are pursuing right now. We are doing this by basically 3 different product lines, being the outdoor series that's coming with a certain resistance class of the housing so that you are protecting your technical setup. The N series, which is from technical side identical but implemented in-house. And then we have a new development called the H2 genset, which is bringing the hydrogen fuel cells in a mobile autark system directly to short-term usages in, for example, construction areas, events, movie productions. The basic technology behind it is pretty the same. So what we are doing right now is that we are scaling up the 2.5 kilowatt hydrogen fuel cells up to your demand. In this case, we see a 5 kilowatt solution, which was originally set up for the backup power of the Behördenfunk digital radio communication in Germany, covering 72 hours of backup power. In order to have the system complete, of course, we also need the controller unit, which is taking care of the operation of the hydrogen fuel cell, and is also monitoring the safety devices that are implemented in our system. We always think about energy solutions. That's very important. And this is also why we are monitoring the pressure reduction stages here, in this case, from 300 bar to 14 bar, 0.5 bar above atmospheric pressure into the fuel cells. And this setup is very important to understand. So the electrification side and the supply side, because we are adapting this also in our indoor solutions and the mobile version. So we have a very good field experience with this technology. The technology itself can be applied in different manners. So, of course, we can use it as an uninterrupted power supply for telecommunication towers. That means that we are directly replacing the grid in case of an outage. With the new versions, we also can adapt it as an off-grid standalone power supply, which can also be fed by a second source, being, for example, solar cells to prolong the time that you can, the energy that you have available on site. We are on the market with these systems for roughly 10 years and several hundred applications. So we have very good experience with this. The way we are applying it usually is that we are placing the fuel cells, the controller unit, the power distribution, and also the inverter technology in one cabinet. And we are combining it with the hydrogen storage that can either be placed in a separate cage, in a separate housing, or also integrated in one big cabinet on the left side. So depending on your requirements and your setup on site, of course. We are also implementing our fuel cells in indoor solutions. Here you can see an application at a university where we applied a 10 kilowatt system indoors for R&D purposes. It's very important that you see how easy it is to apply such a solution indoors. The only interfaces you have to take care, basically, is the air intake on the right upper side, air outtake on the upper left side. Of course, the H2 supply, which is located directly above where the light is, and then the electrical connection into your grid or the whatever system you are feeding with the power. The systems allow us also to scale the 2.5 kilowatt modules up to 50 kilowatts in this technology development. So we realized applications in this size, and we are also seeing a growing demand for higher power. That's also why we are developing a 50 kilowatt module, which is currently in R&D phase and will be available beginning of next year. Maybe if you came by train, you directly passed our booth from SFC, and probably have also seen our H2 genset, which is the latest development from us. What we have done here was that we integrated the fuel cells within a mobile application. So we put it on a trailer, attached Type 4 automotive tanks on it, and made it as an very, very easy set it up as a very, very easy diesel generator alternative for construction sites, for short-term usage, for events, for movie productions in inner city circumstances, for example, where you have high requirements on CO2, NOx, fine dust, and of course emissions. What we have done here was that we have implemented Type 4 tanks with 14.6 kilograms at 700 bars. So you can have more than 240 kilowatt hours with you. So if you go on a construction site, you stop by a H2 filling station, fill it up, go to construction site, have a very silent, emission-free, sustainable way of producing energy, do your job, go home, fill it up, and do it again. If there's a necessity for more power, we, of course, also have the availability of a separate H2 supply via bundle or trailer, completely depending on your demand on site. And what you are seeing here is, of course, CAD and renderings. What we have done to go from renderings to a real-life product is we set up firstly a demonstrator which had a slightly different shape than the latest design. Here we tested this with the THW. It's an organization in Germany, and they had a kind of a pain because of the noise level of the diesel generators. They were only supplying electricity for light, so it was a pretty low requirement, which can easily be covered by in this case, 5 kilowatt generator, and in the future by our 10 kilowatt generator. We also tested the setup in Vienna, in an inner city construction site, which was moving through the city. And of course, the benefits are obvious. It's very, very silent. You can barely hear it. It's only the ventilation. It's emission-free. No CO2, no NOx, no fine dust. And this was really a huge benefit. I mean, imagine you were living in this house here. The construction site is never fun. If you can get rid of a diesel generator, it's slightly better, isn't it? This is the latest design we have shown at the InnoTrans with a partner together. And you can now see in which direction we are going. This is really a direct diesel generator replacement. So the barrier for an end user is very low because, I mean, what's important at the end? You need electricity. You want to plug it in, and it has to be working. And this is what we realized. So from an end customer perspective, this is your interface, and that's basically it, if you're using the internal tanks. We also have a booth here, directly at the main entrance, 13C04. So we have this setup shown at our booth. Please feel free to come and take a closer look. I'm very happy to share more details, and probably there are even some ideas growing in your mind where you can apply a thing like this. I'm very happy to help and to probably solve some issues you're having regarding power supply. So please feel free to come by and contact us. Thank you very much for your attention.
Thank you, Michael. We have 30 seconds for a question. Does anyone have a question? We do have a question.
Gregor Zus von Erevo. Ist es möglich, das System geladen hinzufahren, oder muss es vor Ort geladen werden?
It is possible to fill it at the station and then transport it to the area where the energy demand is. So you don't have to refill it at the station, at your area. Yeah. But I see you have dealt with this topic because of this is one major obstacle to cross. It's the regulation, of course, for road transport. So if you're interested, if you have some experience, please feel free, then we can have a deeper talk. And of course, it's not limited to 30 seconds, probably here, but please feel free. Yeah.
Yes, thank you. Michael Weis from SFC Energy. Hope to see you back here next year.
Thank you very much for the invitation.
Thank you.
Thank you.